Good day, everyone. Before we start, we would like to express our gratitude to the organizing committee for the opportunity to participate at the conference. In these politically challenging times, the European university we represent stays as a private Russian university famous for the educating and engaging independent thinkers and scientists. There will be three of us presenting today out of a bigger team of 5. Ivan Bibilov and Ivan Usalko are with us online. Our plan for today is following. I will begin with discussing critical challenges in building a modern system of digital knowledge in social science and humanities. Then our data analyst Olga Tushkanova will present pros and cons of the Wikibase in regard to these challenges and later describe some practical solutions developed by our team. Then our head of the project, Kira Kovalenko, will tell about the PhytoLex database in more detail. Here on the screen, you see the 5 main challenges which, in our opinion, are particularly relevant to the scientists and research groups in social science and humanities. The first being pluralism of the storage formats. It may basically lead to 2 difficulties: compatibility, since these formats evolve into different versions over time, and the possibility of formats withdrawal from the market when a company stops its development and support. The next challenge is a representation of the data. The most common digital data representation standards often lack convenience for an ordinary researcher. While scanning, recognizing, and publishing the documents in PhD formats is a crucial process for building a digital system of knowledge, it is expensive, demanding in terms of funds and human effort, and it is arguably only the first step on a long way towards making the data of these documents accessible. Other formats of data representations like Excel or CSV sheets allow processing the data with modern advanced technology, but they demand an advanced level of skill in programming and professional understanding of machine data pre-processing. Another common challenge we see over and over in our work, in the work of our colleagues, is the successful interdisciplinary collaboration. Most commonly, specialists in social science and humanities delegate the creation of a database to outsourced commercial companies not specializing in scientific projects. The development in these instances is often based on an initial technical specification rather than an agile methodology. As a result, the created base formally contains all the necessary data, but it doesn't provide a convenient search mindful of all the particular qualities of the data. Hence, the development of a convenient data structure and efficient search demand well-managed collaborative work of both technical specialists and researchers of the subject. Another significant and common challenge in constantly changing digital products is obsolescence. The requirement for functionality, usability, aesthetics, ethics are shifting over time, and significant resources are needed simply to keep up. Which leads us to the last challenge for database projects in social science and humanities, which is limited funding and shortage of institutional support. The digitalization of knowledge includes the collection and pre-processing of the data, the development of database structure with efficient search tools, and a website, and finally, well, the support of the created system. With often limited fundings granted to research in social science and humanities, developing and maintaining such projects following modern technologies becomes particularly challenging without the institutional backing of research centers or universities, thus reducing the cost of software development and support may prove critical for the success of such research projects. Olga?
In our project, we address these challenges by transforming the PhytoLex database into the Wikidata format using Wikibase software. Wikibase, as an open source software operating Wikidata, is one of the largest and most popular knowledge graphs on the modern internet. Important advantages of Wikibase that we need to mention are, first of all, its availability and broad community support as open source software. This makes Wikibase easily accessible for projects with limited funding. Also, Wikibase offers promising solution to the problems of obsolescence and the support of software as well, since it is a core part of the globally used Wikidata It has a well-designed roadmap and development strategy. Worth mention that Wikidata also received funding from major players in the IT industry. And second of all, Wikibase has out-of-box services and wide range of technical tools such as MediaWiki, Wikibase repository and client, MariaDB relational database, Elasticsearch, Blaze Graph, and SparkQL framework, all of them being conventionally integrated into a Docker container for easier setup. The standard Wikidata components allow a relatively smooth integration of knowledge from a local database into the Wikidata graph, and the integration of particular project into a highly advanced ecosystem of digital knowledge thus becomes more accessible. However, as for the PhytoLex project and other rather complex projects, further software development might be required. Next slide, please.
Now, I'm going to tell about database which was used as a case study. PhytoLex is a relational database modeled in the Django framework. It contains information about plants and how they were used in Russia. On the screen, you can see the structure of the first database that was created several years ago. At that time, we worked on the linguistic project and were interested mostly in words denoted plant names, their distribution and history. So the database included fragments of texts created in the 11th, 17th centuries, plant names, etymology, and detailed information about sources. This year, we started to study plants in the 18th century and investigate them from the anthropological point of view. As a result, the database structure became more complex, and you can see that on the screen. It contains much more classes and fields and includes various types of data. Also, there are special components to make the work of the curators easier. Here you can see a component for PDF markup. The curator can select a piece of text in the PDF file, and it will be automatically included into the adjacent field in the form. The complexity of the new database made it difficult to get necessary information, so we transferred our data to the Wikibase with the help of the adapter.
For synchronization of PhytoLex data, we use Wikibase information container, or Wikibasic, which is in fact standard technology of Wikibase. The Wikibasic provides a high level of compatibility of formats for both storage and presentation of knowledge. The container distribution package is updated synchronously with the components update. To preserve the limited resources we had for the PhytoLex project, we optimized the work of the container to 4 gigabytes RAM. To address some issues that ready-made MediaWiki plugins have, like lack of input wizards or complex model forms and processing logic within them, we have developed the adapter for the Django framework integration that allowed us to create predefined forms for administrators and specialized forms for data entry. The Django Wikibase adapter is an integration layer between Django and Wikibase that works at the database dialect layer for Django. It supports flexible solutions for synchronization between an existing database and its open data copy in Wikibase. The architecture of Django Wikibase adapter is built on a query compiler and an action API adapter. The database query flow in Django presents a sufficient level of abstraction, allowing the implementation of the Wikibase query function. Due to the extreme simplicity and flexibility of the Wikibase model, Django concept mapping can be implemented in many ways. At the moment, we are using a direct way as shown in the slide. However, there are still some difficulties in implementing the Django Wikibase adapter. The most crucial are the delayed one-way synchronization between the SQL store, MediaWiki, and the SparkQL service, and the lack of Wikibase type validation. To solve the first problem, we have to build the code into the adapter for synchronized data updates in SQL and SparkQL stores. Standard MediaWiki Action API allows us to work with SQL storage. All the data sample requests go through a SparkQL point provided by the service. The lack of Wikibase type validation we compensate for with special checks transferred to the adapter model. Next slide, please. Sparkle endpoint we have created where one can write queries and download the results in the formats he needs, is open for a public use. Next slide, please. And well, we suppose this approach to be promisingly useful for other projects in the Django framework, and we are ready to answer questions if you have any. Thank you very much for your attention.